An extraordinary place and an extraordinary project by Polish astronomers. In the heart of the Atacama Desert, right next to the world's largest telescopes, a new observatory belonging to the poles has been established. In this program, we will show what possibilities this opens up. Welcome to Astronarium.
The Atacama Desert is one of the driest places on Earth. It hardly ever rains here, and the sun is almost always shining. However, these harsh conditions for humans create unique opportunities for astronomical research. This is why the largest and most advanced telescopes in the world are being built here. And now scientists from Poland also have a new observatory here. Bogumil Radajewski would like to welcome you to this special episode of Astronarium straight from the Atacama Desert in Chile. We are coming here to meet Polish researchers who will conduct observations from this area. We will see how their work is supposed to change what we know about the universe. So let's go.
Observation.
The Atacama Desert is called a paradise for astronomers for a reason.
This is why the extremely large telescope, the world's largest optical instrument for studying the universe, measuring as much as 39 meters in diameter, is being built here. Right next to the summit on which the dome of this giant rises, however, there is another observatory. Astronomers from Poland have managed to place their own telescopes in this special place. The Cerro Murphy Observatory is located on the grounds of the European Southern Observatory. The facility belongs to the Nicolaus Copernicus Astronomical Center, and astronomers conduct research here as part of the Araucaria project. They are involved in improving methods of measuring cosmic distances. As they explain, their own observatory in the middle of the Atacama Desert is an invaluable help in such research. It is one of the largest observatories.
Astronomical, because first of all, we are at quite a high altitude, 2,800 meters. It's already quite significant, and thanks to this, the amount of water vapor above us is relatively small, which allows for astronomical observations that are not heavily affected by atmosphere. The second thing is that we are in the desert. As the name itself suggests, the desert is quite dry. Thanks to the lack of rainfall and the dryness, also no clouds form above us that do not interfere with our astronomical observations. We have about 330 cloudless observation days in a year here, so these are truly the best conditions in the world for conducting observations, astronomical. Having an observatory in such a place is always a great advantage because, first of all, it is an observatory where we can allocate observation time to our own projects however we want. That's the biggest advantage in my opinion. And the fact that we are in this place where we can conduct those 330 nights observational days in a year, sometimes even more, allows us to really conduct projects that require a large number of observations, a lot of observation time, so that they can be realized. And all these elements contribute to the fact that you can conduct precisely such research as the Araucaria group conducts.
As the scientists from the Araucaria project explain, directly measuring the distance separating us from, for example, distant galaxies is not possible. One must start from objects that are much closer and gradually, step by step, proceed to increasingly distant indicators. Polish scientists start with measuring distances to stars in the Milky Way. Based on this, they can determine the distance to similar objects in the Large Magellanic Cloud, a small galaxy neighboring our own. This in turn allows estimating the actual brightness of the Cepheids located there, a particular type of pulsating stars. Cepheids are also visible in more distant galaxies. They can therefore be used to calibrate another type of objects and thus further. At each step of this distance ladder, precise observations of many different types of objects are needed. Their quality determines the accuracy of the final result. This is exactly what the telescopes in the Atacama Desert are used for.
We are talking about the so-called distance ladder. That is, we determine distances to the closest objects to us, and based on these distances, we can then calibrate relationships to slightly more distant objects. Once we know the distances of these slightly more distant objects, we can calibrate relationships to objects farthest. To observe such objects, you need very clear skies, very lot of time, and very many observations. All these three elements are met thanks to the observatory, the OCM, here at the Cerro Murphy Observatory. Because we have telescopes exclusively for our use, we can observe the objects we want, and for as long as we want. No large telescope would give so much observational time for a single specific project to, for half a year, observe only one star. Here we observe for those 6 months many such stars, and in such conditions that allow achieving the best possible accuracy.
The Cerro Murphy Observatory houses several instruments of varying sizes. Among them is one with a diameter of 1.5 meters. It is the largest fully Polish-made telescope to date.
This telescope has 3 mirrors. The main one, with a diameter of 1.5 meters, a secondary and a tertiary, which directs the light beam to the camera. It can actually direct it in 2 directions. So 2 instruments can be attached here. Currently, a CCD camera is connected to the telescope, along with a set of filters that are placed in the filter wheel. Such a set allows for observations in multiple bands. Each filter cuts out a small piece of light, of the visible light that reaches the telescope. Each of these filters is sensitive to a slightly different wavelength of light. Thanks to this, if we conduct observations using several filters, if we have an observation of a given object in multiple bands, we can carry out very precise studies. By comparing the brightness stars in these filters to find out more about what the structure of such a star is, for example. If we are talking about pulsating stars, well then it allows us to learn about how this star pulsates and consequently how it is built. At this moment we are on the upper floor of the entire building where the telescope is located, and beneath us in the room is a spectrograph. The spectrograph is called BESO. It is a sensitive spectrograph that will also work with this telescope. The spectrograph allows us to study a specific section of a star's spectrum, but in detail. We can simply to see how the brightness of a given star changes at a certain wavelength, which in turn allows us to identify what elements are in the star's atmosphere, what the star is made of. This is the largest telescope here at the observatory, but also the largest Polish telescope. Meanwhile, here at the observatory there are currently 5 instruments in total, 5 telescopes, the largest after this 1.5 meter one. These are basically 2 of the same diameter, with a diameter of 80 centimeters. One of them, Iris, which has an infrared camera, and the second, which observes just like this one, invisible light. Besides them, there is also a 60 centimeter telescope, which also observes invisible light. There is the same set there, which is a CCD camera and a filter wheel. And there is also a fifth telescope, which is operated not by observers here from the OCM and not connected with Araucaria, but by the University of Potsdam. It is a robotic telescope.
These are not all the instruments that are to be sent to the Polish observatory in the Atacama Desert. Plans are already in place to build 2 more telescopes with quite different parameters.
These will be 2 extremes. The first will be a 3 centimeter telescope, also called the Japanese telescope, as it is in cooperation with a group from Japan. This telescope is to have an infrared camera mounted and is meant for observing very bright stars, which are usually too bright to observe with such large telescopes. That is why such small telescopes are needed. And the second telescope that is to be built will be even larger than this one, as it will have a diameter of 2.5 meters. This 2.5 meter telescope will allow the Araucaria group to expand their current research, or even quasars, which are a group of objects very distant from us, but also fitting into the profile of scientific research, namely the calibration of the distance ladder, to very accurately calibrate such relationships through which we can determine distances to these objects. Continuous observations of the same ones are necessary. Objects, let's say, for several months or even longer. And to achieve such effects, well, the only way is to actually have your own instrument, your own observatory, and really several telescopes that can observe the same objects simultaneously. Because to calibrate such relationships besides requiring long observations, a lot of observations of this type of objects are also needed.
To coordinate the work of many instruments, the observatory has been largely automated. The system allows for programming observations and, if necessary, even remote operation.
My role at the observatory is integrating systems that are for reading images and operating telescopes, and integrating this with automated systems and automatic control of these telescopes. Thanks to these systems, we are able to manage all the telescopes at once from a single point from our command center, which is located in the main building here at the observatory. The software also allows us primarily to operate these telescopes in automatic mode, which enables us to create an observation plan for a given night and then execute it. And the telescopes are practically almost able to observe the entire night by themselves with minor interventions by the observer involving correcting discrepancies in observational plans, because we cannot estimate everything precisely regarding time. There are also unforeseen external factors, such as the weather, for example. Therefore, it is required for observers to be here on site and able to react to these situations if necessary. However, theoretically, we are currently able to control these telescopes from Warsaw, Poland,
and conduct observations.
How did the observatory in the Atacama Desert end up in the hands of the Poles? The facility was originally built by the University of Bochum and the Catholic University of the North in Antofagasta. In 2020, astronomers from the Araucaria project took it over thanks to the support of the Ministry of Education and Science and a grant from the European Research Council. The observatory was thoroughly modernized and equipped with new telescopes. It gained a second life and a new name, Cerro Murphy Observatory, named after Rolf Cini, from the creators of the original facility from the universities in Bochum and Antofagasta. What is the purpose of the research conducted at the Cerro Murphy Observatory? We pose this question to Professor Grzegorz Pietrzyński, one of the creators of the Araucaria project. As he emphasizes, measuring distances is not an end in itself. The knowledge of the exact distance from various celestial bodies is of significant importance in their research.
Our group is involved in measuring cosmic distances, which are becoming increasingly important in modern astrophysics. If we do not know the distance to a given object, we do not really know what it is. And currently, astronomers are studying objects with increasing precision, which means we need increasingly better distances. So we perform a series of complex astronomical observations. Our group uses probably all techniques, any that are currently available for astronomers, namely interferometric methods. We apply photometric spectroscopic ones. All this to exploit the full potential of those distance indicators, to measure these distances as accurately as possible. And that is precisely why the observatory project was created. Well, here we really need a huge amount of data. We need dedicated telescopes for this project, which is why the whole group here contributes very significantly to the construction and development of the Polish observatory in Chile.
The Araucaria project concerns research on the distances to relatively close galaxies. However, it does so with the best precision in the world. It can then be transferred to even larger cosmological distances. This is how the so-called distance ladder works. Research conducted from the Polish observatory in the Atacama Desert can thus help in solving one of the biggest problems in modern astrophysics. It's about the discrepancy in determining the so-called Hubble constant. It's one of the fundamental physical values describing the rate of expansion of the universe. However, different methods of estimating it provide different results, and this should not be the case. An accurate knowledge of the distances to galaxies may shed some light on the reasons for this intriguing discrepancy.
The Hubble constant is not a constant. Of course, we know this very well. It is a parameter. Recently, we learned that it has changed again. The value is changing, right? Our universe is accelerating. It is the proportionality factor between distance and the rate of expansion universe. So if we change the Hubble constant twice, then the size of the universe would also change twice. Please note that in this concept of the expanding universe, it is also related to its age. The inverse of the Hubble constant tells us how many years old our universe is, so it is a very important element of modern cosmology. The Hubble constant appears in the equations of the state of the universe. If we want to say what the universe was like, what it is like, and what it will be, meaning to understand its entire evolution, we must determine the Hubble constant very accurately. Furthermore, having several methods to determine the Hubble constant, we use this classical method, right, with the standard candles and direct distance measurements. But the Hubble constant can also be determined, for example, by analyzing data from the Planck mission. Then we just measure the Hubble constant at another stage of evolution of the universe. And now we have a very big problem understanding why these measurements differ. In fact, modern physics is not able to explain this, and perhaps such research will lead to the emergence of new physics. There are three possibilities, right? The first possibility is that we modify our physics, well, as has happened many times before. It turns out that it is impossible. There are over 2,000 papers showing that it is not feasible to modify our physics. So we are left with two explanations, or entirely new physics. Already some physicists, astrophysicists, have started working on this. or something is wrong with the errors, right? Our errors are underestimated, and we might think that we measure better than we actually do. And then additional analysis of this data could show, for example, that the measurement error is intended. So we are, of course, focusing on the second issue, the second possibility. We try to determine the accuracy of our distance measurements as precisely as possible.
Unraveling the problems related to the value of the Hubble constant is an ambitious but very far-reaching goal. The research by Polish astronomers at the Cerro Murphy Observatory can also have applications in many other fields, expanding our knowledge about various types of celestial bodies.
As we often say in our team, high mountains are just an excuse to get into the mountains to be and enjoy the beautiful views. Here, our excuse is measuring the Hubble constant, but we are really improving our knowledge of the entire field of astrophysics. By studying Cepheids, we learn about pulsations. Studying eclipsing binaries, we determine the physical parameters of stars with remarkable precision, which is of immense importance for the theory of evolution. So here is all the stellar astrophysics that we apply and also enhance, right, our knowledge in this area. Besides, we have several other projects being carried out at this observatory. They are more or less related to measuring cosmic distances, but not necessarily. For example, monitoring quasars, which are active galactic nuclei. They also allow us to determine distances, but along the way we learn about the physics of black holes, so there are many different studies and they impact various fields of astrophysics.
The Cerro Murphy Observatory is undoubtedly an important achievement for all of Polish science. Having our own equipment in the best place in the world for conducting astronomical observations not only creates new research opportunities, it also serves as proof of our country's determination and commitment to efforts to unravel the mysteries of the universe.
Sometimes to reach the most extraordinary mysteries of the cosmos, one must go to the most extraordinary places on Earth. The Atacama Desert is certainly the best proof of this. I am very happy that astronomers from Poland will now have their new place here, and I eagerly await the results of their research. That was Astronarium. As always, thank you very much for your attention and see you next time.